we are going to discuss another important topic of SystemVerilog, that is SystemVerilog data types. We have already studied data types in Verilog. Let's make a brief summary of what we learned in Verilog. Okay. So data types in Verilog. What are the basic data types in Verilog? They were nats and variables. It was divided into two types, nats and variables. In nats we have wires, and in variables we had res, integer, time and real. So let's discuss what is nat. Let's see what is nat. A nat is used to connect parts of a design, okay, such as get primitives and module instances. Nat comes in many forms, but most designers use scalar and vector wires to connect together the ports of design blocks. Now, see, we have already discussed a wire is a Verilog data type used to connect elements. Okay. Now, default value of wire is Z, and how we used to write wire? We will write the keyword wire, along with it we will write the variable names. Next, we will go to variables. So, in variables, we have the res type variable. So, how we used to write the res type variable? In scalar form or in vector form. In vector form, we will give a res. Here I have shown you a vector form of res 7:0 m, and it is unsigned. Okay. Res, the default value of res we have already discussed it in Verilog. It is x. And what is the keyword? We use the keyword res to write the res to write the res data type. Next, we will move to integer data type. We already know it is 32-bit. It stores signed values. Default value of integer is x. And integers are generally used for declaring loop variables. So, example, when we will use the keyword integer, then we will declare the variable names. Next, we have time, another time data type in Verilog. So, time, it is used to store simulation time. It is of 64 bits. It is unsigned. Then we have real. Real variable can store floating point values and can be assigned the same way as integer and res. The keyword is real and the default value of real is 0. And all of these can hold 4 state values, that is 0, 1, z and x. 0 is false condition, 1 is true condition, z is high impedance, and x is it do not care or it doesn't contain any value. Okay. Let's move on to the next slide to see what are the different kind of data types in SystemVerilog. So the new data types in SystemVerilog, see, so many are there. SystemVerilog, actually what happens, SystemVerilog adds many new data types to help both hardware designers and verification engineers. Because we will see later that there was like many disadvantages with the data types in Verilog. These new data types will overcome those disadvantages. We have two-state data types, four-state data type like logic, then queues, dynamic and associative arrays, classes and structures, union and pack structures, strings, enumerated types like type df and enum. Okay, we will discuss these things later. Today we will go through only two types, that is logic, which is a four-state data type, and the different kind of two-state data types. Now let's come to the logic data type. So here what you can see, that SystemVerilog has introduced this logic and it can replace the res and simplify modeling. Like res only, it can store a value. Then logic can be driven inside always blocks in procedural assignment, and it can also be used like wire in continuous assignments. And it supports 4 state values 0, 1, x and z, and default value is x. So it is a flexible replacement for res. Now let's see why we are using the logic type. The one thing in Verilog that always leaves new users confused. Is the difference between a res and a wire? When driving a code, which should we use? How about when we are connecting blocks? SystemVerilog improves the classic res data type so that it can be driven by continuous assignments, gates, and modules in addition to being a variable. It is given the name logic as some people new to Verilog thought that res declared a digital register and not a signal. A logic signal can be used anywhere. A net is used, except that a logic variable cannot be driven by multiple drivers, such as when you were modeling a bidirectional bus. In this case, the variable needs to be a net type such as where so that SystemVerilog can resolve the multiple values to determine the final value. I will be explaining this with examples. Let's see the examples, okay? So, we already know, I have already told you that a logic variable cannot have multiple drivers. I will be showing you with an example. In case of multiple drivers, we will use the net kind of data type, which is wire. If we will use logic variable in case of multiple drivers, it will show you compilation error. So you cannot drive it with two different always blocks. Okay, in logic type cannot be driven by two different always blocks or by any two multiple drivers, two or more multiple drivers. Now let's see one example. Example 1. Okay, here we have used logic in an always block and it is a procedural assignment. See, always com we know, okay, we have not gone through it, but always com is a procedural construct. Earlier we in Verilog we have always at the rate of sensitivity list. That means that same thing is used for combinational circuits, flip-flops, latches, everything. But if we use the always com, then it is like if we use the always com, then it is like it will always infer a combinational circuit. If we use always FF, there is one more procedural construct called always FF. If we use that always FF, it will always infer a flip-flop. But these varieties were not there in Verilog. We will be discussing these things later. Just for your understanding, I am using this always com and showing you a procedural assignment. How using logic we are using in a procedural assignment. Okay, first of all we are using the logic, then we have given the variables. Okay, then we have used the always statement, begin and end, between begin and end we have used sum is equal to a XOR b. Okay, what will happen? This sum will store a value. So logic is the right choice. We don't have to think whether we have to use res, wire. Earlier in Verilog we have to think in case of continuous assignment we have to use wire for doing physical connection. In case of this one, for storing a value in procedural blocks we have to use res. So we don't have to think all those things in SystemVerilog. We can directly use the logic. Now let's see how we'll write a always block. Okay, replacing the Verilog res. This is a always block using res. Earlier in Verilog we used to use it in the res out, then always at the edge of project block. Then in the procedural block we are giving out, then we are storing the data in out. But in SystemVerilog we can use logic. Okay, this is how we are using logic in procedural block. In case of res, it is much cleaner and more meaningful. So let's see when not to use logic in SystemVerilog. Okay, if there are multiple drivers, you cannot use logic. You have to use wire, otherwise your system will show compilation error. Now see, wire A, assign A. We are giving multiple driving values to A. A equal to X and A equal to Y. So multiple drivers are allowed only on wire. If we will use logic, then if we will compile it, it will show some error. So let's have a brief summary of where to use logic, where to use wire, and where to use res. Okay, in case of Verilog, wire is used in left hand side of continuous assignment and res is used in left hand side of procedural assignment. But in SystemVerilog we will be using logic, and it can be used in both always blocks and assign blocks. Okay, remember these things. And logic and res can store value. Wire cannot store value. It is only used for physical connections of primitives or gates. And multiple driving value, wire can be used for multiple drivers. Logic and res cannot be used for multiple drivers. Just remember these things. This is the summary of your whole logic part. And remember that the default value of logic is X, and it is a 4-step data type. Okay, now let's move to the 2-state data types in SystemVerilog. Here we will be having one bit, byte, int, shortint, longint, and these data types can take the value 0 and 1. Bit is unsigned, and byte, int, shortint, longint, everything are signed data types. You already know the difference between signed and unsigned data types. Still, I will be discussing here. So, what is happening in 2-state data types? They can only take two values, 0 and 1. We cannot use X and Z values in 2-state data types. And why we are using these 2-state data types? Okay, they help us to improve the simulator speed, and it also reduces the memory uses, as it does not require additional bits to encode like X and Z values. Okay, so it cannot be used to represent X or uninitialized state. X and Z will be automatically converted to 0 in case of 2-state data types. These are typically used in testbenches. In design, we use 4-state variable like logic, and in testbench we will be using 2-state variable. The default state or default or initial value of the 2-state data type is 0. If we will not initialize the 2-state data types, then it will give us the value 0. Okay, remember these things. Now we are moving to bit. So bit is how much? It is a 1 bit, or we can also use it as a vector. See, I have shown in the example bit A or bits. Then we have given a range 7 to 0 data. That means bit 7 to 0 is a 8-bit unsigned integer. Okay. And what is the range of the unsigned values? It is 0 to 2 to the power n minus 1. So if the since it is a 8 bits, so how many values we can count? We can count values from, it can take values from 0 to 255. Okay, remember these things again and again. I am telling bit is 1 bit, bit A is 1 bit, and bit 7 is, when we are giving the range, since this is 7 is to 0, it will be 8 bits. Okay, if I give 31 is to 0, it will be 32 bits. And remember this thing, it is unsigned, and it can, the range of unsigned value is 0 to 2 to the power n minus 1. So it can take values from 0 to 255, and it supports factors. This one is one example, and this is a 1-bit data type. Okay, let's move on to the signed data types, that is byte, shortint, int, longint. Okay, byte is a 8-bit signed data type. Then shortint, we have can store 16 bits signed integer. Okay, shortint, so it is half of int. Int is, it can store 32-bit signed data type. Longint, since it is long, it is double of int. Okay, so it can store 64-bit signed data type, and the range of signed values is minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. Okay, this is, see, this will be n minus 1. 1 is missing here. Okay, so the value, if in case of byte, the how many bits it is, since it is 8 bits, so we can count values from minus 128 to 127 in case of byte. Okay. Suppose you may be tempted sometimes to replace your logic 7 is to 0. Suppose it is logic 7 is to 0, you may be tempted to replace it by byte. Now, hardware designers should be careful as these new types are signed variables. So, a byte variable can only count up to 127, not the 255. You have to remember it again and again, okay? You could use byte unsigned, but that is more verbose than just bit. You can use byte unsigned. Then you can use values from 0 to 255. Okay. Now let's move on to the, suppose you have got a bit A is equal to 1 bit BX. Then what value you will get? You will get the value is equal to 0 since it is 2 step. And again, if it is logic B equal to 1 bit BX, then we will get value, the value of B will be equal to X. So output will be A equal to 0 and B equal to X. So let's see the difference between 2-state and 4-state variable. 2-state, we have already seen the different data types. It can take the values 0 and 1. In case of 4-state logic, 4-state data type, we are using the keyword logic and the values are 0, 1, X and Z. Okay. What is the use of this 4-state logic? It is more accurate in modeling. Okay. It is useful in finding netlist bugs, as it shows compilation errors in case of multiple drivers. And what is about the 2-state variable uses? It improves the simulator speed and it reduces the memory uses. Default value of the 2-state data type is 0 and default value of logic or 4-state data type is X. Okay. Now there is another keyword called $is unknown. Okay. When to use it? Be careful, okay, when you are connecting 2-state variables to the design under test. Earlier I told that in case of design under test, we use mostly of the 4-state variable, but sometimes we may use the 2-state variable, okay. In that case, we have to be very careful, especially with its output. If the hardware tries to drive an X or Z in the design, okay, these values will be converted to 2-state value, and your test bench code may never know, okay. So don't try to remember if they are converted to 0 or 1. Instead, always check for propagation of unknown values. Use the $is unknown operator in that case. What happens if you use the $is unknown operator? What happens if the value of the data is equal to X or Z? That means, okay, it is don't care or some high impedance value. Then $is unknown will show the value as 1. Okay, it will return a 1 if any of the bit or expression is X or Z. So this is very important if we are using 2-state variable in the design, because test bench, whoever is making the test bench, they doesn't know whether we are using 2-state variable or the 4-state logic variable in design. So if we are using 2-state variable and like some bits are coming as X and Z, how we'll know? We have to use the $is unknown, and if it is X or Z, then it will return a 1. That's all for today. Thank you.